Hi students, welcome to our channel. Our today's topic is motion under gravity. Okay. So what is the previously we have some knowledge regarding motion of bodies in a straight line. So what about this motion under gravity? Have we to learn any new things here, or our old knowledge which we applied for motion in a straight line, is it enough? Why we have to put a special heading for this motion under gravity? What is the difference between the previous motion and this one? That is, previous motion we dealt motion of bodies in horizontal line, horizontal straight line in one direction. So why can't we apply the same knowledge here? Let us check. See, for bodies moving in a straight line, we use different sets of equations. If it is a uniform motion, we use this equation S equal to Vt. We used this equation S equal to Vt when for uniform motion, that is when the body is moving with a constant velocity, we used only this expression. There is only one mathematical expression to solve problems regarding bodies moving with a constant velocity, and that sole expression is S equal to Vt. Then this equation S equal to Ut plus half At square. These are kinematic equations when A equal to constant. A equal to constant means what? Uniform acceleration. So for the bodies moving with a uniform acceleration in a straight line, we used these equations to solve problems. So next one, V equal to ds by dt, A equal to dv by dt, or V dv by ds. This is another set of kinematic equations which involves calculus part of mathematics, and these equations we used when A is equal to variable. When acceleration is not constant, these equations are not suitable. If a body moves with variable acceleration, we cannot use these equations. These equations are meant only for bodies moving with a constant acceleration. I am reminding you once again. So here these equations, we can apply these equations when the bodies move with variable acceleration. And not only that, don't think that always if acceleration is variable then only we can apply these equations. Even if acceleration is constant, in such cases, in some scenarios, we have to use these equations. In which cases, when the velocity is expressed as a function of time or as a function of displacement, or acceleration is expressed as a function of time or as a function of displacement, to find instantaneous values, we use these expressions. Okay, so okay, till now there is no problem because the motion is along a straight line in a single direction. Now let us consider this set of equations. So here this set of equations, this is for bodies moving with constant acceleration, you know. Okay, now let us consider this case, motion along a straight line. So let us consider this is the starting point of motion. So a body starts its journey with some initial velocity u. What is the direction of initial velocity? Rightwards. At any point in this journey, see, we are considering from O to, suppose A is the end point of this journey. So from O to A, what is the direction of velocity? V is always rightwards. Then what about displacement from here? This is the initial point, this is the final point. So this is the displacement vector. So displacement vector is also rightwards. And what about acceleration? In this case, suppose if velocity is changing now in this direction, acceleration in this case, suppose if velocity is increasing, So acceleration is in this direction. So directly all the physical quantities are in same direction. So no need to bother about minus sign convention. We used the equations simply like this without bothering any minus sign. Only in one case we bothered about negative sign, that is regarding acceleration and deceleration. For acceleration we considered plus a, and for deceleration we considered minus a. That's all. For acceleration we considered plus a, for deceleration we considered minus a. So while writing the equations, wherever you are dealing with acceleration, you put plus a. If you are dealing with deceleration, we just put minus a there. Now what about this case? Motion under gravity. Motion under gravity. So here motion under gravity means what? So a body's motion is influenced by Earth's gravitational force. Suppose if this is land, Earth's surface, and if we project a body in a vertically upward direction, what happens? Earth's gravitational force acts on this body. When the body is at this position or at this position or at this position, at any position, this body is acted upon by gravitational force of Earth, Fg equal to F equal to mg. So what does it mean? In this direction the body is having acceleration. In this direction the body is having acceleration. Since the acceleration is due to Earth's gravitational force, we are designating this one as symbol g. So here in which direction g will be there? G will be always in downward direction. If a body is moving up, what is the direction of g? Downwards. Acceleration is downwards means what about deceleration? Deceleration is in this direction. Deceleration is in this direction. Deceleration is in that direction means what? Velocity. Deceleration means what? Velocity is decreasing. In which direction velocity is decreasing? In this direction. As we move in this direction, velocity is decreasing. Suppose here velocity at this point is 10 meters per second. Here it is 7 meters per second. Here it is 5 meters per second. Here it is 3 meters per second. In this way velocity is decreasing. Finally at this position velocity is 0 meters per second. So see in which direction it is decreasing? In upward direction it is decreasing. What? Velocity is decreasing as we move in upward direction. See, let us move downward direction. At this point let us move in this direction. At this point what is velocity? 0. At this point velocity 3, 5, 7, 10. As we are moving down velocity is increasing. As we are moving up velocity is decreasing. What does it mean? In downward direction velocity is increasing means what? Acceleration is in downward direction. As we move in upward direction velocity is decreasing means what? Deceleration is in upward direction. Clear? So why this happens? Because gravitational force due to Earth is acting in downward direction. Always acceleration will be in the direction of force. So how do you know? Because we know from Newton's second law, F bar equal to ma bar. LHS is equal to RHS here. So here the magnitude of LHS is equal to magnitude of RHS. Not only that, since there are these are vectors, not only magnitude, direction also must be same. So here force vector on LHS side and acceleration vector on RHS side, they should be along same direction. They should be along same direction. Okay. So here it is very clear that the direction of acceleration is same as the direction of force. So in what direction gravitational force is acting? Downward direction. Therefore, what is the direction of g here? G is also in downward direction. So the body's acceleration is in downward direction. Clear? Okay. See here, a body which is thrown up, it is having motion in two directions. One is upward motion, another one is downward motion. So here the problem arises. So we cannot directly apply the kinematic equations S equal to ud plus half v d square, that batch. We cannot use them directly. We have to consider sign convention there. So the problem is how to assign sign convention. Students generally they commit petty mistakes regarding the sign convention issue. So in this video I am going to make it very simple. Let us make it very simple. The sign convention problem will be made very simple. Okay. Let us divide the motion under gravity into two categories. Number one is freely falling bodies. Freely falling bodies. And number two is bodies projected vertically upwards. So freely falling bodies and bodies projected vertically upwards. So what are freely falling body means what? Freely falling body means what? Just hold a body, leave it, it falls down. Okay, such a motion of a body is called as freely falling body. So what is the direction of its motion? In downward direction. Let this be origin point and let this be ground. So this is final point here. So now let us consider initial velocity. What is the direction of initial velocity? U is downwards. What about final velocity? Here final velocity V is downwards. Don't think that final velocity means velocity at this position by the time it reaches ground. We can consider velocity, this velocity, this velocity. Suppose if you are asked to find velocity concerned this point, then this will be final velocity, no? Final velocity depends upon our problem. Okay, this could be final velocity, this could be final velocity, this could be final velocity. So at every other than this is the only point of initial velocity, and any remaining point can be considered as final velocity point, depends upon the problem. So at every point, what is the final velocity direction? Downwards. Okay, initial velocity, final velocity. Now what about displacement? See, this is initial point, this is the final point. So body displacement, it is along this straight line. So displacement is also, so this is displacement, no? From O to. So displacement, how is displacement? Displacement is also in downward direction. Initial velocity and final velocity are in downward directions. Displacement is also in downward direction. What about acceleration due to gravity? This is also in downward direction. Then see all the physical quantities. All the physical quantities are in downward direction. All the physical quantities are in one direction. Then there is no need to think about negative sign. So why do we require considering negative sign? If some physical quantities are along positive x direction and some physical quantities are along negative x direction, then there is requirement of choosing negative sign. So all the physical quantities which are directed in this way, they are assigned positive sign, and all the physical quantities which are directed in this way, they are assigned negative sign. So if the physical quantities are directed oppositely, then we require negative sign. See here all the physical quantities, initial velocity, final velocity, displacement and acceleration due to gravity, all these are directed in one direction, downward direction. So in this case, just no need to think about negative sign. Just don't bother about negative sign. So freely falling body case is very simple. We can directly use the equations. So just replace A with G in the kinematic equations. So simply we can use those equations, no problem. Now the case is with the bodies projected vertically upwards. See what happens here? If a body is projected vertically upwards, so what happens? Here we can study this case under two cases. Case 1 is this one. This is case 1. Case 1, only upward motion. So case 1 we are going to consider only about upward motion. See what happens? After reaching the maximum height, the body again moves downward direction, moves in downward direction. We are not bothering about that one. Okay, so we are considering only upward motion. And in case 2, we consider both upward as well as downward motions. So let me draw that one also here. So this is origin, body moving up, body moving up and coming down along the same line. Okay, but for our convenience, let me draw the line here. Some students may think that the body is moving actually like this. No, it is not moving like this. It is going up and coming down strictly. It is purely a motion in a straight line. Okay, don't draw this one. Actually, this line also lies on this line only, but for convenience, we have taken this line forever like that. Okay, so now case 1 is only upward motion, and case 2 we consider both upward as well as downward motion. So now what to do? So just check. For usage of negative sign, do only one thing. Note down all the physical quantities corresponding to this case. For the physical quantities which are in upward direction, put upward arrow. For the physical quantities which are in downward direction, put downward arrow. For upward arrow, give positive sign. For downward arrow, give negative sign. That's all. So no need to bother, or no need of any confusion regarding the uses of negative sign here, right? So let us see. Here this body is projected in vertical upward direction. So what is the direction of initial velocity? Initial velocity u is the velocity at this particular point. This point is known as point of projection. At this point, what is the direction of initial velocity? In upward direction. So what about final velocity? Here its value is 0, but by the time its value becomes 0, in what direction the body is moving? In upward direction. So final velocity is 0. As I told you before, velocity at any position can be considered as final velocity. So throughout this journey, final velocity is in upward direction only, right? Okay. So initial velocity u is upwards, final velocity v is upwards. What about acceleration a equal to g? It is downwards. Whether the body is moving in upward direction or the body is moving in downward direction, acceleration due to gravity is always in downward direction only, always downward arrow only. Why? Because as the gravitational force is acting in downward direction. Okay, so what about displacement here? Displacement. See, this is initial point and this is final point. So what is the displacement? From definition, it is the straight line joining, it is a straight line drawn from initial point to final point. So this is the displacement vector. So if we consider this point as the final point in the problem, so this is the displacement vector. Suppose if you consider this point, then what? This is the displacement vector. If you consider this point, then this is the displacement vector. If you consider this point, this is the displacement vector. If we consider this one as final point, this is the displacement vector. If you consider this one, this is the displacement vector. Okay, so see here, throughout if you consider this part of motion, displacement vectors are in upward direction. So what does it mean? So displacement is also having upward arrow here. Then what about acceleration due to gravity? It is having downward direction. Do we require to consider negative sign here or not? Yes, because some physical quantities, initial velocity, final velocity, displacement, all these are having upward arrows, while another physical quantity, that is acceleration due to gravity, is having downward arrow. So opposite directions are there, we have to consider negative sign. Now the case is very simple. So how we use the equation? For example, s equal to ut plus half at square. Simply you write here in the place of displacement, here we use s equal to h, because we are measuring heights. No, we are measuring heights here. So let us write. So this is the basic equation. S equal to ut plus half at square is the standard equation. Now let us substitute the corresponding values for this case. In the place of s, let us write h. This is ut and this is plus half. In the place of a, we have to use the symbol g. Can I use plus g or minus g? Here displacement is positive, so plus h. Initial velocity is positive, plus u. So what about acceleration? It is a downward arrow. Downward means negative. This is plus, this is plus, this is plus, this is minus. So this is minus g, this is t square. So this is equal to h equal to ut minus half gt square. Okay. Similarly, v equal to u plus at is the raw equation, standard equation. So in this case, v is positive, v equal to u is positive, plus a equal to minus g. So this t. So the v equal to u minus gt. Got it? So we can use all the, so in all the standard equations just replace a with minus g, that's enough. So this case is also simple case for us. Which case? Considering only upward journey. Okay, got it? Let us consider case 2. So here this is origin point, this is, let this be point A. If this is point A, what is this point? This is also point A only, because this line actually lies on this line. Body moves from O to A and again from A to O, the same straight line. So this point is also A only. And what about this one? This point is also same point O only, right? Now in this case, what about initial velocity? Initial velocity means velocity at this position. Otherwise, let us take this one as A dash and this one as O dash, because these 2 points corresponding to downward motion and these 2 points corresponds to upward motion. For discrimination, just let us put minus sign there, right? So what about initial velocity? Initial velocity is at this position. U is upwards clearly. The body is projected upwards means, okay. At this position, what about velocity here? Velocity V equal to 0. So velocity V is 0. So at any point in this journey here from O to A, velocity is upwards. Then what happens after it reaches A? It comes down in this part of journey. So here in this case, let us consider this is U equal to 0 and here final velocity V. See here, initial velocity means velocity at this point only. Then what about final velocity? Final velocity could be this point at a point B. Let us choose a point B here. So here final velocity could be at this point. In the reverse journey, final velocity at the same point B will be some V downwards. So throughout the journey, final velocity in this part of journey will be in upward direction and final velocity in this part of journey will be downward direction. But initial velocity means velocity corresponding to this point only. Final velocity means it corresponds to any point throughout the journey. It is depending on the problem. So what about U here? U is upwards. What about V here? V is upwards as well as downwards. Both possibilities are there. Okay. See, in previous case, in upward we considered only upward motion. There V is only positive. So V only in upward direction. But here in this case, V could be in upward direction as well as downward direction. What about acceleration due to gravity? It is always downwards. Even if the body is moving from O to A in upward direction, then also acceleration due to gravity is in downward direction only. Here when the body is moving in downward direction, in that case also acceleration due to gravity will be in downward direction. Whether the body is moving up or it is moving down, acceleration due to gravity is always in downward direction, as I told you before. So here, what about displacement? So this is the starting point, no? When the body is moving in upward direction, what is the displacement? Displacement vector is in upward direction. Now after reaching point A, when the body is moving in downward direction, then what about displacement? It is upwards or downwards? Most of the students whom I questioned about this one, they answered, they gave me wrong answers. Simply they told me displacement is downwards. Why? They are thinking that if the body is moving down means when the body is moving up, displacement is upwards, means when the body is moving down, displacement is downwards. In that way they are thinking. See, displacement, the displacement does not depend upon the path of journey. It depends only on initial point of the journey and a final point of consideration. So when the body is moving up, what is final point? This could be final point, this could be final point, this could be final point, this could be final point. In that case, the displacement vector is in upward direction. Now what happens when the body is moving in downward direction? Once it reaches point A, going up like this, reaching point A, then return journey it comes like this, At this point, see, this is the same point, no? This is B point, no? B dash. At this point, it is moving in downward direction. But what is the displacement? See, this is initial point, no? This is same point. Actually, this arrow is on same point, no? So we have to consider these 2 points are same, these 2 points are same. So what is the displacement from here to, from ground level to this much height? You have to draw this arrow. Okay, so displacement is in upward direction. See here, even if the body is moving in downward direction, displacement vector is in upward direction or not, because this is initial point, this is final point. What is the definition of displacement? It is a straight line joining, it is a straight line drawn from initial point to final point. That is the displacement definition. So this is initial point, this is initial point, this is final point. So initial point to final point we are drawing. Just don't bother if the body is moving up or moving down, or it can go somewhere and come here. Just don't care. Even if this body goes like this, from here it goes like this, goes like this, goes like this, goes like this, and comes here, then also displacement is same, this one only. Why? Because from definition. So in this case, displacement vector is always in upward direction. Okay, then one more. So okay, here, see here, u is upwards, acceleration due to gravity is downwards, velocity is both upwards and downwards, displacement is upwards here. That's all. So depending upon the situation, you assign negative sign or positive sign. Let us take this expression for example. S equal to ut plus half at square. So what is S here? S is always positive. S equal to, what is u? U is always upwards, put plus here, and this one minus half gt square, because a equal to minus gb. So let us consider one more equation, v equal to u plus at. In this case, what about v here? V could be upwards as well as downwards. So what to do? Suppose you have to find v, just write v like that. No need to assign any sign, because the sign of v, they will be decided by these quantities. So what about u here? Plus u. U is always upwards, no? What about a here? This is minus g. So v equal to u minus gt. One more thing, suppose if you have to find initial velocity, when final velocity is given to you, you have to find initial velocity, then you have to assign sign. If it is a given quantity, assign sign. If it is not a given quantity, don't assign sign. The quantity which you have to find, never assign any sign to it. Keep that point in mind. That is one tip here I am giving you. So which quantity you have to find, even if it is upwards or if it is downwards, just don't bother. Write the symbol of that quantity like this. The remaining physical quantities in the expression, they decides if this quantity is in upward direction or downward direction. So this thing you can understand in a better way while solving problems. In next video I will come with the problems. Be in touch. So let us have one round up here. In the case of horizontal motion, there is no problem regarding usage of sign convention. We can use all the kinematic equations as they are. In the case of bodies moving under gravity, for freely falling bodies, no need to think about any sign convention, because all the physical quantities are in downward direction, that is one direction. Okay, so previously I told you, upward direction you consider positive sign, downward direction you consider negative sign. Here again no need to put negative sign, because all the quantities are in one direction, so just no need to bother about sign here. So what about bodies projected vertically upwards? We studied this case under two conditions. One is considering only upward motion, in other case considering both upward as well as downward motion. Okay, in the case of upward motion, initial velocity is upwards, final velocity is upwards, displacement is upwards, acceleration due to gravity only in downward direction. And in this case, here initial velocity is always upwards, displacement is always upwards. Whether the body is moving down or it is moving up, displacement is always upwards. And velocity could be upwards and velocity could be downwards. Acceleration due to gravity is always downwards. Just don't bother about anything while making equations. Just write these quantities and give the respective arrow marks. Then by seeing that arrow mark, you can assign sign convention in solving problems. The case is very simple now. Okay guys, let's meet in our next class with the problems, so that you can better understand how to solve problems very easily regarding motion under gravity. Let's leave.